Hi, science students. Welcome back. Let's go ahead and deconstruct AKS 9C. Let's first read the AKS. It says, develop models based on experimental evidence that illustrates the phenomena of reflection, refraction, interference, and diffraction as applied to mechanical and electromagnetic waves. This is a lot to unpack. So let's first mark the key vocabulary. I know that I'm going to mark develop models. I'm going to mark experimental evidence. I'm going to mark the word phenomena. I'm going to mark reflection, refraction, and interference. I'm going to also mark diffraction. And lastly, I'm going to underline mechanical and electromagnetic waves. We've talked quite a bit about electromagnetic and mechanical waves. So let's start there. We're going to write some examples on those little lines that we've highlighted. We know that an example of mechanical waves would be sound. And there are other examples of mechanical waves as well, but we're going to use sound. And electromagnetic waves, the most commonly used example is going to be light. Let's jump up to the top, up here where we have our science and engineering practices. So first we're going to start with developing models. Developing models is going to mean that we are creating a visual representation to show our understanding. This visual model might look like a 3D model that we've built, but a visual model can also just look like a drawing. So when we see the word model, it doesn't have to be a 3D diagram. It can be something that I've drawn out visually to create a representation of my understanding. Experimental evidence is going to mean data that I've gathered during an experiment. So let's go on to this word phenomena. So phenomena is going to be some kind of scientific situation or occurrence that we can observe. In physics, what we're doing this first semester, we're doing a lot of observation of phenomena, things that happen in the world around us that we can observe and explain as to why they are occurring. Let's keep going. Let's look at reflection. So reflection, refraction, interference, and diffraction are all going to be behaviors of waves in different scenarios. Maybe when they run into an obstacle, maybe when they hit a barrier, maybe when they run into each other. So we're going to talk about each of those individually, and with my pen, I'm going to use 4 different colors to represent these to kind of keep it a little easier to tell which one I'm talking about. So let's start with reflection on the far left, and I'm going to draw an arrow down like this, and I'm going to write reflection as a little header. I'm going to zoom in just a little so it's a little easier for you to see. All right, so reflection is going to occur when waves hit an object that they cannot pass through. We know that certain materials that are transparent or translucent will potentially allow light to pass through, but objects that are opaque are not going to allow that to happen. They're either going to absorb the light or they're going to reflect it. So when it hits that object that it cannot pass through, it's going to either be absorbed or it's going to be reflected. And if it's reflected, it's going to bounce off of that object. So I'm going to draw a small little model right down here of what reflection would look like. So I'm first going to draw my surface, my mirror, and try to make it look straight. It should be a flat surface. Mine's not exactly flat, but this will do. And then I'm going to draw my light wave. Actually, let's start with my normal. So my normal point is going to be an invisible line in the middle that shows me where the ray actually hits the surface. So if I've got a light wave traveling in to here, like such, this ray is called the incident ray. And so I'm going to write that incident ray. So the incident ray is the one traveling towards the object before it hits it. When it hits the object at the normal point, it then is going to bounce away, and that's going to be called the reflected ray. Let's go on. Refraction, and I'll use a different color, purple here. I'm going to draw my little arrow down, and I'm going to write refraction. So refraction occurs when waves bend as they pass from one medium to another. This is due to a change in speed. We know that not all medium travel at the same speed. We know that gases move faster than liquids and liquids move faster than solids. So I want to add that on here. So waves bend as they pass from one medium to another due to a change in speed. That's really important. That's the reason that refraction occurs. So I've drawn a little cup of water here, and I'm going to use this as my example to remind me of what refraction is. You've probably seen this example before. So if you were to place a pencil into a cup of water, the pencil appears to be bent. So I'm going to try the best that I can to draw that. So my pencil is going in to the water, and then as it hits that water and I'm looking at it, it's going to appear to bend. The pencil's going to look as if it is bent, even though we know that it isn't. And that's because the liquid is not moving as fast as the gas is. So as that ray of light travels from one medium, the gas, to another, the liquid, the way that we see it is going to appear that the wave is bending because of the change in the speed. Let's keep going. So we're going to look at interference now. Interference is right here for us. And I'm going to use my red pen for this one. And I'm just going to draw an arrow straight down over here. Put my little header, interference. And if you're a football fan, interference is a term that we hear a lot. So interference in the case of waves is going to occur because two or more waves are going to arrive at the same place at the same time. Interference can be constructive or destructive. And we've probably heard those words before, but maybe not in this particular capacity. So interference, if it's constructive, the waves are going to combine And constructive interference occurs because two waves at the top of their wave interfere at the same time, and it actually increases the amplitude of that wave. So constructive waves are going to combine and increase amplitude. Destructive are not going to be the same. So destructive is going to be when two waves arrive at the same place at the same time, but they are not the same parts of the waves when they interact and they actually run into each other. It might be that the top of one wave runs into the bottom of a second, and instead of combining and increasing their amplitude, they're actually going to do the opposite. They're actually going to cancel one another out, and that is how noise canceling headphones work. So destructive interference is going to cancel out each other and decrease the amplitude of both waves. Diffraction is going to be our last behavior of waves as we're deconstructing here. And so I'm going to use my pink pen and I'm going to draw a little arrow down like this. And I'm going to write diffraction. So diffraction is going to occur as waves pass through barriers or run into obstacles. When they run into that barrier or they have to move around the obstacle, it actually causes the wave to spread out in a different shape than it was moving before. So I'm going to write that, and spread out. So I might draw an example of this where I have my mechanical wave traveling like this, and then maybe it runs into a doorway, right? So here's my barrier, and that sound wave or that mechanical wave is trying to travel through. And when it travels through that barrier, it changes the shape and it becomes more of a rounded shape as it passes through. So diffraction can happen because it had to pass through a small space like a window or a door, but it also could be that it runs into an obstacle and has to move around it. So let me zoom you out just a little. This is a lot of information to take in. So if you need to pause the video in order to record any of this, please do so. Have a really great day.